Alright, today we got ourselves here a 27-inch late 2009 iMac, and this one's in here for a graphics card replacement. Graphics cards are known for failing on these older units just because they tend to overheat, and after this iMac sucks up a whole bunch of air, it collects a lot of dust. Over time, that dust can act as an insulator and can essentially choke the graphics card, and when that happens, it can eventually fail. The most common 27-inch known for graphics card failure is the 2011 models. This one's a 2009. It's old, so just looks like the graphics card had failed. So we're going to go ahead and jump into replacing this one. And the reason I wanted to do a video on the graphics card replacement for this model is because the graphics card is actually behind the logic board, which means we have to disassemble the entire computer just to even get to the graphics card. And it's one of the more complicated repairs, but there are a couple of benefits to it. One, we can go ahead and remove all the dust while we're inside, and two, since we're right next to the CPU, we're also going to apply some new thermal compound. So on top of making the graphics card replace so it starts working again, we'll also put some new cooling paste onto the processor. So overall, this will actually run more efficiently than it did before. So we'll start into it. We can see cosmetically this one has been dropped during a move, and the glass we're going to replace at the end. The thing with these iMacs, cool thing, is they're held together with just magnets. So if you want to get some suction cups, and just grab the corners and pull your way. Just like that, the magnets release, and you can pull off the glass. Now the new iMacs, everything after 2011, so like the 2012 models, are bonded with adhesive. So you can't pull them off with suction cups as simple as you could with this one. All right, so now that we've removed the glass, we're going to have a total of 4 screws on the left and 4 screws on the right, so a total of 8 screws holding the LCD down in place. And I believe these are T10s. The screwdriver is going to be a Torx 10. And you got these little magnets right here all along the side, and that's what actually held the glass down. And while we pull out the screws, we'll see that the screw is going to be magnetized. It's going to get stuck on these magnets. Don't worry, just use some tweezers and pull them out. Just like that, that one got stuck to the magnet as well. And in some cases, around the ones that don't have magnets, they'll fall behind the screen. And if it falls behind the metal bracket right here, don't worry about it, because once we remove the screen, you'll be able to have access to the screw itself and just pull it out with some tweezers. All right, we got that side. Let's start working on the right side now. So we have our 8 screws removed for our LCD. Now the LCD, we just want to grab the top corners. We're going to lean it towards us ever so slightly to pull it out, but don't pull all the way. It's a little hard to see. You can see right here we have a V-Sync cable. So just simply grab it, pull it out like so. And then we'll have 3 other connections. So this is going to be our LVDS cable, and that's the display cable, what actually sends the data to the display, the image that you see. So we'll remove that. Over here on the left side, this is going to be our backlight power cable, and it's kind of got a clip to it. So you're going to push down on the clip, pull that part out, and then last we have the LCD temperature sensor just hanging right here. And that one we just pull straight on out. So once we have all of our 4 cables disconnected, we'll pull this out and take the LCD and flip it facing towards our wall here so we don't get any more dust on it that's already there. Surprisingly on this one, the inside of it's actually really clean. I do see what looks like some nicotine smoke and dust buildup right here. It leaves like a orange to yellow stain in the fan. Other than that, we've seen some that are much worse, especially given that this is a 10-year, almost a 11-year-old computer. This one's actually in really good condition. So before we pull out the motherboard or the logic board, we will have to remove the power supply to give us some wiggle room. the super drive, so then we can also remove the fan. Once those are removed, we can then pull the logic board out. So for this guy, we have a little styrofoam stand I'm going to stick in there just so the mount itself doesn't move around. So this is just a styrofoam stand, and its sole purpose is to prevent the body of the iMac from tilting. You can see it's pretty solid on there, and that's just going to prevent things from falling towards us. Let's pull out the power supply first. The power supply is also a Torx 10. Make sure you have your power cable disconnected when you're doing this repair, because the power supply is fully exposed, and if you touch the wrong thing, you will electrocute yourself. Apple themselves, when they had their technicians servicing this, they would have like a plastic shield called a power supply cover that they'd put on this to prevent their technicians from getting hurt. We don't have access to those tools, but just make sure that this is fully unplugged. It's probably sat for maybe 30 minutes to an hour. You can even hold the power button to discharge some of the capacitors in here, and just avoid making direct contact with anything on the power supply. So the power supply is held with two cables. So we have one cable down here. It's held together with tape. We're going to pinch this. You can kind of see that cable right there. Pinch it and let go. So there's that side. And then this is going to be our main power rails that go throughout the rest of the computer. So we want to disconnect that as well. Same thing, it's got kind of like a pinch clip on the other side of the power supply. Now I'm just grabbing the side of it, trying not to touch any components, and just wiggling back and forth until it popped off. And move this guy a little closer so you can see in a little bit more detail what's going on. So we've disconnected this power supply cable and the bottom power supply, and we have all of our screws removed. Make sure that you screw map too. Just remember the placement of these screws, because the power supply uses 3 different types of screws. You want to make sure they all go back in the same place. Now just grab the side of the power supply and pull straight out. And we'll set that to the side for now, and we won't need that until we're reassembling the computer. So now we have that out, we are going to remove our super drive, which will then give us access to remove our fan. Super drive also uses a T10 screwdriver, and we have 4 screws around the super drive. And the super drive, it's called a super drive rather than a CD drive. It is ultimately an optical drive, but it's called a super drive because it spins at 10,000 RPM, so it's faster than a normal CD drive. Alright, so this guy right here, this is our temperature sensor on the super drive, and it just goes down to this part of the logic board. So make sure that you unplug the temperature sensor before you remove the super drive. And then the super drive has a SATA cable right here. It's a mini SATA cable, so it's going to have the power and the data cables connected. And we're just going to wiggle that guy out. I'll actually use a black spudger just to get in there and separate it. Cool. Just like that, it's removed. So we'll set this one to the side as well. And this is our SATA power and data line. And now that we've removed that, we'll have access to remove our fan. And we just need to remove the fan. We don't need to remove the right speaker. And the reason we had to remove the super drive is because the super drive has almost like a spacer for closing off airflow, I'm assuming. And it's the spacer is part of the fan that goes underneath the super drive. So you can't remove the fan until you remove the super drive first. So we'll just wiggle this through. We got 1 screw and 2 little standoffs right here. Alright, and then disconnect your fan. Fan terminal is right next to your temperature sensor terminal. So we'll take our fan, we'll set it to the side as well. So those are all the obstacles out of the way. The inverter board sometimes can be removed. That's completely optional, but we should have enough wiggle room to remove the motherboard too. And this is a little plastic shield, you could say, that separates the inverter board from the power supply. It also cuts it off from the airflow that the CPU fan pushes, so it doesn't heat up the inverter board. It heats up the power supply. Airflow goes through the top of the iMac. Now we'll just have to end up removing, oh, we also have another one of those shields for the power supply. This is to the right side. We'll remove that as well. So now we're at the step to where we can go ahead and remove our logic board screws so we can take the logic board out itself. Optional, you can remove the hard drive, but it's not really necessary. So I'm gonna get just this is a magnetic screw set, and really it's just a magnet that's in a baseball card holder, and we're gonna use this to keep track of our screws for our logic board. The logic board also uses a T10, a Torx 10 screwdriver. And you all have to remove every screw. You'll see, if you're doing this repair yourself, you'll see there's arrows pointing on the heatsink that shows you which screws you need to remove. All the other screws around here, this is what's going to hold the CPU in place. We don't need to remove these just yet. In fact, we don't want to remove them at all. It'll actually make our job a little harder if we remove them. We got a screw right here in the center. And we have a screw over here on the right side. Screw right next to where the fan was. Oh, missed this one, so we have a screw right next to our heatsink over here on the left side. And then we have a screw that's holding our GPU heatsink in place. So now that we have all the screws removed, we'll have to remove our cable terminals, all the cables that plug into the logic board for various things. So like over here on the left side, we have our CPU fan. We'll remove that. Our power button's connected right here. And we're just going to go through and unplug all of these cables. What I do have to credit Apple for on this is all of the terminals here, they're all different shapes. So it's not easy to get them mixed up. So you really don't have to keep track on these. Just unplug them and then we'll put them back together. This long cable in the 2009, this is going to be our airport card cable. And it gets in the way. I'm just going to remove it for now. So it looks like all the cables are unplugged, and then to make things a lot easier, we have our IR sensor that is built into the Apple logo. And this was for if you had iTunes or QuickPlay, or I'm sorry, QuickTime, you can use a remote to actually control your computer for skipping to the next song or fast forwarding the videos. Not too many people use that feature, but to make pulling out the logic board a lot faster, we're gonna pull that part straight out right now. So it just slides directly out. So we grab it and just pull it out like that. You don't have to unplug it. It is taped down. It has its own cable right here, but just pulling this guy out makes pulling the rest of the logic board out. So everything looks good to go. I'm going to set my fan screws, my logic board screws all over here to the right side. Now comes the step of removing the logic board. I recommend pulling out the logic board from while this guy lays on its back. Oh, one last thing too. We need to remove the RAM. RAM's going to be hiding underneath this trap door. And that is going to use a Phillips head. We got 3 screws down here. I recommend removing the trap door from the memory slot while this is standing up. It's a lot easier to gain access to. So 3 screws, this guy pops right out. Then you're going to have see if I can get this in view. You're gonna have like these black little pull tabs that are tucked in there. See? And pull down on them, and you get your RAM slots. Your RAM pulled out of the RAM slots. So all of our RAM's out. We'll set this to the side. Now we're finally able to pull the logic board out. So we no longer need this guy. We can remove our stand, and I'll set this down on its back. So this is a good view of how you want to pull the board out. The board you're going to lift up at a 45-degree angle and pull it straight out. Oh, and another thing too, so the board won't come directly out. We still have our cable that plugs the power supply into the logic board. That's going to be tucked in underneath here. So we'll have to grab that cable and kind of shimmy it out as well. And that's it. We also have our SATA cable that is taped to that same power cable. I'm just going to pull that out. And other than that, we're ready to pull the logic board out. So here we are. Now we get to see a really good take on the logic board. So this is the back side. When you open up the iMac, these are the sides that you see. The back side, this is where our graphics processor and our CPU, our central processing unit, is hiding, and there's really not that much dust. I mean, there is if you rub your finger across it, but the fact that this is an 11-year-old computer, this isn't bad. So we'll no longer need this. I'll just set this to the side with the rest of our parts. What we're going to be focusing on now is removing our GPU, and the GPU is already screwed into this heatsink. We're going to remove this entire heatsink. We're going to take our new graphics processor and transfer it onto the new heatsink. So you're just going to remove 3 screws. You'll remove the 2 screws right here that hold the card to this mounting bracket, and then you're going to remove this screw up here that holds the rest of the heatsink to the mounting bracket. Then once all of that is unscrewed and you've unplugged your temperature sensor, you're going to lift up the card at a 45-degree angle like so, and lift straight up. So there's our graphics card. So let's set the logic board just a little bit out of our way so we can focus on our card. And the card is on the back, hiding underneath our heatsink. So we'll have to remove the heatsink, and we're going to remove the thermal paste in the process. And there's 2 ways you can go about this. You can either unscrew the Phillips head screws right here, or you can unscrew these T8 screws on the back. I personally like to remove the T8s from the back side. Oh, I'm sorry. These are T10s as well. And once you have removed your 4 T10 screws, you'll have this little bracket, X bracket on the back. Keep the orientation in mind because we will have to put it back the exact same way. One side is going to be a little bit longer than the other. And now we can pull our card from our heatsink. It's going to give us a little fight, and that's just because the thermal paste itself is dried up. So this is all thermal pads or thermal paste for the RAM, and this gray spot, this is going to be the thermal paste for the main graphics processor. Just to show you, all of this right here, this is going to be our RAM, dedicated RAM for the graphics processor, and here is our main processor. And just to show you the importance of replacing thermal compound, let me grab some Q-tips. I'll show you what this stuff looks like. So here is the thermal compound, and I have to really push on it with a Q-tip in order for it to come off. And you see how it's still just like a straight line right there? That's because the thermal paste is supposed to have the consistency of paste. It now has the consistency of clay. It's not really doing a good job dissipating heat. We don't need to worry about cleaning this guy up. This guy's bad, so we're going to end up putting into our e-waste. We will need our new graphics card. And this is the same graphics card, same year. For iMacs in particular, you have to replace the graphics card with a graphics card that was made for this specific year. So there's two graphics cards for this one. This one in particular, this is a AMD Radeon HD 4850. This one has 512 megabytes or half a gig of dedicated memory. For this specific year, you had two graphics cards, either the one that had half a gig of dedicated memory or one that had 256 or a quarter gig of memory. You can't easily put a newer graphics card in from like a newer model or a model that was pulled out of, let's say, a Dell computer. You have to get one that is made directly for iMacs if you want this repair to be pretty straightforward. Reason why is because there are chips programmed onto the graphics card, kind of like drivers essentially, that only work specifically for the Apple computers. I have seen technicians be able to get a newer graphics card and flash the chip that's on here that's responsible for booting up and for working with a Mac. But if you don't have access to those flashing tools, then just replacing the card with the same type of card is the best method. So this one here, it's a ATI or AMD Radeon HD 4850. So this is the 512 megabyte version. So we're going to clean this one up. For cleaning, just use some Q-tips and some isopropyl alcohol. And use a high-grade isopropyl alcohol. We use 99% here. If you get it from like CVS or Walmart, it's typically 70%. You want to get something that's at least 90% or higher. All right, so our card's clean and ready to have new thermal compound put onto it, but we also have to clean up the heatsink as well. And these pads look really destroyed, so I'm going to replace this with a inexpensive thermal paste that's perfect for memory. This one's going to be Cooler Master. You can use this for a processor, but this stuff seems to be better for iPhones and RAM. So this stuff, I think you can get for about $20 off Amazon for 200 grams. And this is the Ice Fusion Thermal Compound Kit. This stuff's perfect for RAM. I don't recommend putting it onto a CPU. For a CPU, I would recommend something with higher viscosity, such as Arctic Silver or MX4 by Arctic. There are other types of thermal paste out there, but I would not recommend Cooler Master for directly the GPU or the CPU. For RAM in this case, it's perfect for what we need. So let's clean this guy up. Okay, so our heatsink looks a lot better. Time to clean it up with some isopropyl alcohol. You can also use a paper towel for cleaning the heatsink if you don't have any Q-tips. One of the biggest ways to figure out if you have a bad graphics card in one of these iMacs is visually you'll have lines in the display, or if you ever do anything graphically intensive, let's say play a video game or watch something on YouTube in like 1080p or 4K, this computer won't play 4K, but it'll try. It will crash and make the computer lock up, or you'll have to force restart it, or the computer itself turns off. Another way you can diagnose if a graphics card has failed is if the computer never boots up. If it kind of takes forever on the Apple logo and you're either getting the bar going up all the way or you're getting the spinning ball underneath the Apple logo, but it never boots up all the way, that could be an indicator that the graphics card is not able to load up the proper files, the KEX files, to make the Mac OS operating system load up. And how you can mitigate that and prove that it's a graphics card issue is, as the computer's turning on, hold the left shift, and if it boots up into safe mode, which is what the left shift button does, and everything seems fine, it's going to look choppy because it's running in a low graphics mode, then that's also an indicator that the graphics card has failed. So we have this all cleaned up now. Now we're going to put some new thermal paste. So we're going to put some Cooler Master on our RAM, and then we're going to put some Arctic MX4 on our main processor. And for applying thermal paste, I recommend doing the dot method. Just get a good pea size of thermal paste onto the graphics card. That way when we put this onto the heatsink, it will evenly spread out across the graphics processor. I don't recommend doing the spread method, and there is a lot of controversy over that. And the reason I don't recommend that for something as powerful as the graphics processor is because there is a high chance that you can create air bubbles in the graphics processors to where the space between the processor itself and the heatsink is not making solid contact and not dissipating heat enough. So I went ahead and I've already put some of the Cooler Master thermal paste into a syringe I have here. I mostly use this for iPhones, but this works great for RAM. And you're just gonna pretend that this is like a honey bun or a cinnamon bun, and you're just glazing it, you're frosting it. Or a cake, whichever way you want to think about it. So we're just building up mounds here, just going around covering the entire chip. You can use the dot method too. For RAM, it's not as crucial as it is for the main graphics processor or the CPU. It's like an electronics toaster strudel. I can hear my wife back there giggling. Okay. Now we're going to put our heatsink onto our graphics processor. For this, I would recommend putting the graphics processor onto the heatsink rather than the other way around. So what we're going to do is take our card, flip it over, and you're going to line up the 4 screw holes with the standoffs that they go into. And try not to lift the card back up once you put it down. And you're going to take your X bracket, lay it over your screw holes, then take your screws that you removed earlier and put them back through. Twist one corner in, not all the way, but just enough that it's held in place. Then get your next screw and do the directionally opposite screw. Kind of like if you're changing the lug nuts or rotating tires on a car. This will allow the thermal paste to push down evenly instead of pushing down one-sided and pushing the thermal paste out. This is going to go down evenly. So we'll turn this a few times, then we'll go directionally opposite. Next to that, just keep twisting. And our heatsink is on. I need some more Q-tips. Now I'm going to inspect the card as well as clean the contacts to make sure there's no oil or thermal paste. That way it makes a nice solid connection to the logic board. And we had a little bit of thermal paste right here. These connections look good now. And inspecting the card from the side, I can see that the thermal paste went well onto the RAM slots, onto the RAM chips. And you can't see the actual graphics processor, but it's there. Our card is now prepped and ready to be put in. So let's pull our logic board back and reverse what we did before. So we're going to angle this at a 45-degree angle, and we're going to lay it straight down. Oh, and the screws that hold the heatsink in place to the logic board, those are T8. That's what I was thinking about earlier. And this top left one of the heatsink is a T10. So our graphics card is officially replaced. Do not forget to plug the thermal sensor back into the logic board, because if you do the repair and the fan kicks on really high where the optical drive is at, the super drive, it's going to be because this cable was not plugged back in. You'll have to pull the entire logic board back out for that. So since we're already here, let's go ahead and replace the thermal paste onto the main CPU. And just like we did before, I'm going to pull out the back end, the torque screws. These look like they're T10s instead of the Phillips screws. I stand corrected, these are T8s as well. And if you feel like that the screw is just spinning around in a circle, you may have to apply pressure to the Phillips screw to prevent it from spinning around. I'm going to grab the heatsink and the logic board and flip it over. Just like the graphics processor, there's also a thermal sensor right next to the CPU heatsink. All of our screws are removed. Heatsink comes straight out. And just like before, this thermal paste has turned more into like a thermal clay. So you can see the whole thing's just wadding right up. It's not like paste. And thermal paste, given the name, it's just like toothpaste. It has the same consistency as toothpaste. And we want that consistency. And once it dries up like this, it's not really doing the optimal job of cooling down the CPU. The cooler the CPU is, the better it's going to run, the longer it's going to last. And this is a 11-year-old computer. Let's see if we can get this guy to last even longer. And what I really enjoy about this model specifically, this is the I series when they first introduced the i3, i5, i7. This one's an i5. So this one still runs Mac OS High Sierra 10.13. And High Sierra is still a very well supported operating system and probably will be for another, hopefully another 3 or 4 years before it's completely obsolete. So if this computer can get 15 years worth of usage, I think the client got their money's worth for sure. So we've exposed the processor, and just like on the heatsink, this stuff is completely dried up. So we're going to replace this as well. I'm holding this at an angle so that as the thermal paste kind of just chips away, it falls into this trash can I have underneath me instead of falling back into the board. I'm going to clean the rest with some isopropyl alcohol. Now that our heatsink is cleaned and so is our CPU, we'll take our thermal paste. I mentioned before I like to use this stuff, MX4 thermal compound. I used to use Arctic Silver for a while, but that stuff you'd have to wait for it to set in before it was fully optimal. This stuff, you just put it on, you're good to go. I've noticed between the Arctic Silver and the Arctic MX4 thermal paste, probably about a 5, sometimes 10 degrees cooling difference between the two. Like this will cool better, and compared to the original dried up thermal paste, this is significantly better. So just like before, we'll put a good sized dot, and since I think it's called the HIS or HSI on the processor itself is larger, I'm going to put a bigger ball of thermal compound. And what that is you have this metal plate on the processor, and underneath underneath this metal plate is the actual processor, the die, kind of like what we saw with the graphics card. Well, between the metal plate and the die, you have another layer of thermal paste, which same thing can happen. That stuff can dry up, and you can use a special tool for cracking off the metal piece and replacing that thermal compound. I don't recommend doing that unless you're into the ultra. What is it? It's the is it liquid nitrogen? Okay, yeah. So if you're not doing any crazy liquid nitrogen overclocking, that's what I was trying to say. I couldn't think of the word. I don't recommend doing that on an iMac. You're probably not going to be doing that on an iMac. Don't pull off the heat spread on the actual metal part of the processor. That was a long off-topic tangent. Now we're going to put our heatsink back together. So this is a little tricky. There's a couple of different ways you can do this. What I like to do, I probably should have done that already, so I already messed up, is to take the screws and take the screws that we removed earlier and put them back on the logic board and put some tape underneath them so that they hold their place. But I did not do that. So what we're going to do instead is we're going to put the heat sink back onto the CPU so that these standoff holes stick out. At least they should. Now I'm going to apply some pressure. And I apologize, this is a horrible tutorial on what to have done. And I'm going to go underneath, so I'm pulling the board to the edge so I can hold the screw. Yeah, I'm sure there's a much better way of doing this. So we got one side down now. Can't really show you, I can't really bend the camera, so you just got to believe me that it went down. If you can find a better way of putting this back on, please let me know. I'm sure I'm doing this the worst way possible, but it's working. Okay. It's 2 out of 3 down. That side's down. I should have enough room to flip this over to put the last screw in. So what I'm doing is I'm holding the back end of these Phillips screws and just kind of applying pressure to them so that they don't spin, and then taking my T8 screwdriver and twisting this down. Just like before, I'm kind of rocking back and forth between the 4 screws so that this lays down evenly. And then our CPU now has new thermal paste. Just like before, on the graphics processor, make sure you plug in the CPU thermal sensor back into the logic board. And the last thing we can do is take this this battery here and check and see if it's still reporting the right voltage. It should be about 3.2 volts, so we'll need our multimeter. So let's pop out the battery. I'll take my multimeter here and I'm going to put it into DC measuring, direct current. And there's a plus sign on the battery itself that tells me that it is the positive side. So black goes on the bottom, red on top. And we're getting about 3, essentially. 2.95, we'll round up to 3. So that's still good. The battery is still all right, so we'll leave that in. If it was anything less than 2 volts, then we'd replace it. But, oh, and this one's actually a 3-volt battery, not a 3.2, so it is measuring the right voltage. Cool. Our board is done and ready to be put back in. So I'm going to take a time out here, because what I'm going to do now, since we have the iMac fully disassembled, I'm going to take this outside and just blow out all the dust. There's not that much in here, but we have it completely opened up. Also take the fans, since they look like they're a little dirty, and fix that as well. So I'll be right back. All right, I'm back. So now I've removed all the dust out of the inside of the shell. All the dust was actually just inside of the fan itself, and the logic board itself doesn't need to be dusted. Even the heat sinks look perfectly fine. They don't really look that dusty. Now I'm just going to go ahead and put this guy back on its side and put the logic board back in. We're going to take our power cable and our SATA cable to our hard drive, plug that in first. And that's in. And while inserting the logic board, we're going to make sure all of our cables, all of our wires that we pulled out earlier are out of the way and not tucked underneath the board as we put it in. So like my audio cables down here, they were in the way. So just move that aside. And the power button and the CPU cables, those like to get tucked away. All my cables are out of the way, so now I gotta angle this in. And there's not necessarily a trick to getting this in. You just gotta wiggle it right until you see that the screws for the logic board line up properly. And that's what we got going on here. Gonna make sure all of our cables are pulled out. Beautiful. Looks like all of our cables are out. And everything went back in pretty well. I'm going to stand this back up like we did earlier and put all the cables in first. And the reason I do that is if a cable is still stuck underneath the logic board, we can just lift up the board and put it back in, rather than screwing it down first and then finding a cable's in there wrong and having to unscrew everything and putting it back in. And all of our cables at the time, let's see, actually, are we missing one right here? Skin temperature. Here, so our LCD temperature is on the LCD. The hard drive temperature is not in this unit. Huh. This one may have had a hard drive replaced at one point and someone didn't put the hard drive temperature back in. And then skin temperature. Where is that? Right here is our skin temperature. Cool. Let's start putting our motherboard screws back in. So if you screw mapped your logic board screws, this should go in pretty smoothly. If you didn't, then you'll notice that you have some long screws for the logic board and some small screws. And for the most part, the long screws are going to be in the logic board in these 4 spots right here, and the small screws are going to be right next to the I/O connections, the audio connections, USB connections down here, because that's where the back of the iMac is thinner, so they use smaller screws. Now that our logic board screws are in, let's start putting all our connections, all of the things we took out. So our right fan was one of them. And to show you on the right fan, you'll see that there's 2 standoffs here in the frame, and then the screw hole for the fan itself. Got it. So what I was trying to show is the fan itself has these these little holes right here that go into the standoffs in the frame, and then this one is going to be the screw hole where we put our screw. So line up your standoffs first. And your SATA cable for your optical drive is going to go to the left of this spacer right here. Our fan is back in. Now we'll take our super drive and we'll put that back in as well. So we'll connect our SATA power cable first. And then the super drive itself has like these two little standoffs coming out of the frame. We're going to put the standoffs through the holes on the super drive so that they fit into place. Just like that. Now we're ready for our screws. These were T10s as well. The only part of the computer that has been T8s has been the brackets for the GPU heatsink and then the back of the CPU. Now that we have our fan and our super drive reconnected or re-screwed back in, we'll then take our fan connection and put it back into its terminal on the board, as well as the temperature sensor of the super drive on the board as well. Next comes the power supply, and remember we took off these plastic covers. So this plastic cover on the left side separates the LCD inverter board from the rest of the computer. From the CPU fan dissipates heat off of the CPU heatsink, which then goes to the processor or the power supply, which then comes out of these grills right here. Plastic just guides all the heat away from the inverter board. And then we had another one on the right side which guides all the heat away from the hard drive. And there's some cables. Drop my black stick. So there's some cables here on the right side, such as the eyesight camera and the skin temperature sensor. Just want to make sure that those are out of the way of our plastic spacer. Now that those are in there, we'll have to put our power supply back in. And remember that you should have kept track of the screw holes of the power supply, since they use 3 different types of screws. So I've already connected the main power rails to our power supply, and we're going to hook the rest of our power right here. What this cable is, this is the cable that comes directly out of the back of the computer where you plug in the cable, goes in through the power supply, and then comes out at the top right here and delivers power everywhere else to the computer. And that was held down with some tape. So I'll put the tape back. If your tape is too messed up, just you don't have to use tape. But if you want it to look as close as OEM, just put some Kapton tape back in, and it does the job as well. So our tape is back down. Making sure our spacer didn't pop out. Looks good. And we'll take our screws and we'll put them back in. If you didn't keep track of the power supply screws, your smallest screw is going to go up here in the top left. And your longest screw, which is going to have a different thread style than any of the other threads, is going to go in the bottom left. Let me see if I can get this in focus so you can see. These are probably too shiny for this to focus on. Maybe. I tried to for a second. But this one's going to have a much bigger thread style than the other two. So short screw up here, long screw up here. The 2 screws with the same thread styles here. Let's go ahead and install our RAM. So for the RAM, you'll have these little pull tabs that come out. You want to make sure they're pulled down. You're going to take your RAM and just push it back up into those slots. There's 4 slots total. We only have 2 sticks of RAM in this case. So we're going to put one on one side and the other on the other side. That's another thing I love about these iMacs is the upgradability. Three screws, and you have access to the RAM door, and you can just upgrade the RAM yourself. That's a nice feature. They kept that on the new 27-inch models. It's on the back where the power plugs into the iMac, but they took it away from the 21.5-inch iMacs. Some iMacs you can't upgrade, others you have to pull the entire logic board out just to get to the RAM slots. The 27-inch, they kept it to where you could upgrade the RAM. So our computer, our iMac here is pretty much good to go. We just need to put the LCD back in, and then we'll try to boot into his operating system and see if we fix the issue. So we have everything back installed. Let's put our LCD in. Alright, so let's put our LCD back in. And we have 4 cables we removed, so we're going to put those back in. I recommend starting with the backlight cable. The cable right here that plugs into the inverter board. And then your temperature sensor, the LCD temperature sensor next. And your LVDS cable plugs into this 30-pin IPX connection. And then last, our V-Sync cable. It's up here at the top of our inverter board. For testing purposes, I'm going to just put 2 screws in. That way, if something needs to be reworked on, we can open this up quickly. So one up here in the top left, one here in the top bottom left, one here in the top right, one down here in the bottom left. So one thing that's very common with the magnets on these iMacs is they demagnetize your screwdriver. So my screw just fell back here in the iMac, so I'm magnetizing it so I can grab it. There we are. Now let's grab a power cable and turn this guy on. See if it boots up all the way. And let's see if this one boots up. This one would only boot into safe mode, which was an indicator that the graphics card has failed. If this graphics card works like it should, then it will boot up normally. And what this beeping noise is it's not detecting the RAM. So let's open this back up. And we don't have to open up much because we left our RAM door open. We're going to reseat our RAM slots, our RAM connections. Looking at the pins, they look fine, so it's possible I just didn't put it in properly. That one's in. This one also looks fine, so let's reseat that again. That one feels fine too. Let's try that one more time. There we go. So it's booting up. And let's see if it'll actually boot up all the way. We have some shards of broken glass around the LCD itself too. So we're going to have to blow some of this out. So we just have a lot of tiny shards that are stuck in this felt material around the LCD. Now, what this one would do though is it would boot up halfway and then stay there. And this one booted up all the way, so the graphics card has passed. So it was successful. Let me grab a mouse and keyboard. See if we can boot into his guest mode if he doesn't have internet only. Excellent. Yeah, he's got a normal guest mode account. Alright, so the first thing I see here and about this Mac, it is detecting the graphics card, and it shows Radeon HD 4850, the 512 megabyte version. And if we go into system report, that'll pull up system information to give us more information on the graphics card that it's detecting. So that's going to be under graphics and display. And we see right here the exact same thing, Radeon HD 4850, 512 megabytes. So that is a successful repair. Alright, so I'm back. So I'm looking at this computer, and it does look like someone actually has replaced this hard drive, and when they did the repair, they did forget to replace the temperature sensor. So we're going to open this back up and put our own temperature sensor to mitigate that issue. But I can see someone had actually installed a third-party program to control the fan speed. And while that does work, it's not professional, so we're going to put a new thermal sensor in there so the fan doesn't boost all the way up. Right now, the hard drive fan is running all the way. So other than that, everything else seems to be working just fine on this computer. So we can go ahead and, well, let's shut it down. We'll put a new thermal sensor, then we'll do one more quality control test. Alright, so we got our thermal sensor in its place. Let's put the LCD back in and do one more quality control test. Alright, let's turn this back on, and while this is booting up, since we know that the RAM is okay, I'm going to go ahead and put the RAM trapdoor back on. Alright, so the computer's booted up fine again, and right now the hard drive fan sounds to be normal. So we've remedied that thermal sensor issue. Now I'm just going to perform a quality control test to make sure everything is functioning properly on this guy. Awesome. So everything on this computer passes our quality control test, and now what we'll have to do is there's still a little bit of leftover glass from whenever this was broken. I'm just going to blow this out real quick with our data vac. Then we're going to get the new glass and install. All right, so we got our new glass panel here, and it's got some dust on it just during shipping. So I'm going to dust this part off too. Alright, and that is how you successfully replace the graphics processor on a 27-inch iMac. This one here is a late 2009. As mentioned, this is more prevalent of a repair on the 2011 models, but it can still happen to any iMac with a graphics processor, which is essentially every single iMac. So in this case, it looked like the card was indeed bad. The way how we were able to determine that, which I didn't show on the video, was when the computer would try to boot up, it would get about halfway and then no longer go past the bar. If we booted into safe mode, which is a low graphics mode, we were then able to essentially run off the integrated graphics of the i5 processor in here, and it booted up just fine. So that was enough to tell us that the graphics card itself had gone bad and needed to be replaced. So showed you how to fully disassemble the iMac, how to remove the heatsink with the graphics card, apply new thermal paste onto both the graphics card and the CPU, and to do a quality control test afterwards, make sure everything's working. I hope this has been a very informative video on how to do the repair yourself. If you have any questions or concerns, please just leave a comment. If you like these videos, please let me know, as I'm trying to get more into the habit of doing these about once every other day, just to really share the knowledge that we have learned here. But that's it, and I hope you enjoy this. We'll see you in the next one. Thanks.